So we talked about natural log already. Natural log derivatives and natural log integrals. Run that over 4 days. The lesson today is so easy, we're going to jam it all into one lesson. And that would be exponential functions. In particular, we're going to look at e to the x. Now, don't confuse e to the x with something like x squared. X squared is a variable raised to a constant. E to the x is a constant raised to the variable. The rules change a little bit. This will be fun. You're going to have to do a little work on the front end, and you'll be pleasantly surprised by the results. So today we're going to talk about the properties of natural log function, e to the x. We're going to take the derivative of that exponential function. We're going to take the integral of that exponential function, and I have a quote for you today. Be kind whenever possible. It is always possible. Who said that? Who? I didn't hear what you said.
Confucius. Michael Leonardo da Vinci.
No, it wasn't Leonardo da Vinci.
Confucius.
Gandhi is a good guess, not correct. Close. No. No.
Oprah. Confucius?
Not Oprah. Not Confucius. It's a he, and he's still alive.
Oh,
Dalai Lama.
Donald Trump.
In Spanish, La Lama de Delhi. Thought I'd put that out there. Okay, so here are the first two questions. Solve, i.e. simplify each of those composite functions, please. Look like you're gonna throw up now. It's better. You got answers? Anybody got answers?
I'll know if they're right.
What are your answers? I'll tell you if they're right.
X.
For which one? They're both X? Is that what you're going with?
Sure.
Correctamundo. They're both X. Now, why are they both X? Well, the first one is a natural log of something raised to an exponent, so one of the log properties says you can bring the exponent out in front, and the natural log of e is 1. The second one, you need to be a little sneakier about. You could either remember the property, e to the natural log of anything is that anything, or there's a way that you can get it by doing the natural log of both sides trick, but rest assured, it's equal to x. What does that say about those two functions? The functions being the natural log and the exponential function, e to the x.
Inverses.
They're inverses of each other. Woohoo! Yay! That's what we did yesterday. If you put one function into the other, you get x, and you put the first function into the second, you get x. They are inverses of each other. Beautiful. For those of you that are visually minded, here's a graph. So the gray function we've talked about already, that's the graph of the natural log of x. It passes through the point 1, 0. And based on what we learned yesterday about inverses, if the function natural log of x passes through 1, 0, then its inverse function must pass through 0, 1. And sure enough, it does. What else can you tell me about the graph of e to the x? Or I should say the function e to the x. Always increasing. The fancy term we learned for that, Luke, is? Close. No? You were right, monotonic. Strictly monotonic. So first things first. The function is always increasing. What else? What's its domain? All reals. What's its range?
All reals.
No. Gotcha. 0 to infinity. Always concave up. So remember, the domain of e to the x is the same as the range of the natural log of x because they're inverse functions. The range of e to the x is the same as the domain of the natural log of x because of what we did yesterday. This is a pre-calc question, but it's worth going over. I'd like to solve it. This is not calculus. We're not taking a derivative. I just want to know what x is. So do you remember the trick for solving these equations?
Raise them both to the natural log.
Close. Not raise them both. That's the e to the trick.
Take the natural log of both sides.
Beautiful. Take the natural log of both sides. There's actually two tricks you're going to use. One trick is what we're going to do here, which is take the natural log of both sides. The other one is the e to the trick. So you make each side the exponent on e. We'll get to that later. Okay, so you take the natural log of both sides. And then one of the log properties are, if you have the natural log of something raised to a power, you can move the power out in front. And the natural log of e we already discussed is 1, so we get that. And subtract 1 from both sides. Sure enough, you get that. If you have a calculator, if you're feeling all fancies in your pansies, you could then type that in and get a decimal equivalent. Remember, 3 decimal places, AP standard? Or you could have left it as -1 plus natural log. Any problems? I'm sure your outstanding pre-calculus teacher taught you how to do that. Let's move on. We did that already. That's the that's the limit. Yeah, okay, great. Let's take a derivative. Now, the reason I'm going to ask you the following problem is because we've done logarithmic differentiation already. However, I have a feeling that many of you might need a review. And given that tomorrow is a quiz, this would be an excellent opportunity to review. So please, using logarithmic differentiation, take the derivative of e to the x. And watch the magic occur. Pleasure. Before you go too deep down the rabbit hole, remember, this is not a variable raised to an exponent, so you don't just bring the x down and make it into x minus 1. How many people tried that? Yeah, you're just afraid to raise your hand. There's a reason why I asked you to use logarithmic differentiation, because that's the technique you need to use. Not looking good, kids.
Yeah.
Not looking good at all. Okay. I don't want to mention any names, but one person got it. So you start with the function. What are the steps for doing logarithmic differentiation? No, that's how you find the inverse. Tom,
Take the natural log of 6.
Take the natural log of both sides. Whoops. What's the natural log of e to the x? X. Next step. Tom. Take the derivative of both sides. What's the derivative of natural log of y?
Natural log of y prime.
No. Tom.
Y prime over y.
Y prime over y. What's the derivative of x?
1 over x. No, sorry.
Holy guacamole.
What's the next fruit? Yeah,
1.
Of 42 possible points on the quiz, how many will you get? 1. What's y? E to the x. What the heck just happened?
That's what we're wondering.
What's the derivative of e to the x? E to the x. Oh my God. It's its own derivative, people. This is amazing. This has never happened before. And it will never happen again. It's the one exception to the rule. It's its own derivative. The derivative of e to the x is e to the x. The derivative of e to the u is e to the u. Chained on with the derivative of u. First big mistake that happens coming out of this section is people forget to chain. They see the derivative of e to something, they just write e to the something and be done with it. No. You need to chain. So, what's here to write down? It's its own derivative. Holy guacamole. What's the derivative of e to the 2x minus 1? So you'll recall a couple, like about 6 seconds ago, I said the most common mistake is people forget to chain it on. So then I asked you what that was, and you told me e to the 2x minus 1. And what did you forget to do? Chain on. Just because I'm feeling self-abusive today,
Okay.
I'm going to click just for giggles and see what kind of a train wreck we get here. All right, try that one. I dare you. That one on the quiz might go down to a 0.
What's the derivative of 1? 0.
Yeah.
Whoa.
Coming into the devotion rule for the
You could if you'd like. That's not a stupid comment. Well done. I wouldn't, but you could. Why are you looking at me like that? You want to fight? I mean, we can go right now. I'm on edge today. I've had too much coffee.
Oh boy.
Okay. Anybody want to venture a response? Just for giggles. No, Tom, you've done enough today. Take a break. Anna, you gonna go for it? Ooh. All right, go ahead.
-3 times the natural log of the absolute value of x plus c times e to the -3 over x.
No.
This would be all in text.
We have another volunteer? Luke?
Yeah. 3 over x squared.
That's
e
it.
to the negative 3 over x.
Let's give it up for Luke. All right, Einstein. Why?
Because you have to take the derivative of the negative 3 over x and get 3 over x squared.
The derivative of e to the anything is itself. Chain on the derivative of negative 3 over x. I am not going to review how to take the derivative of negative 3 over x. Quotient rule is a possibility, JJ. Or you could write it as negative 3 times x to the negative first. It's entirely up to you. Yeah. But you get the same answer. Let's move on. This will be fun. If the derivative of e to the x is e to the x, what's the integral of e to the x? Yes. Yes. Redemption. However, when you do the integral of e to the u du, it's not just simply e to the u. You have to do a u du problem. Of all the things that go wrong in this chapter, the following problem will illustrate the biggest mistakes. Or mistake, I should say, singular. What is the antiderivative of e to the 3x plus 1? And the correct answer is not e to the 3x plus 1. That will be too easy. Anybody want to live on the edge? That's actually the integral of 1 over x is natural. Anybody? Should we let Tom answer?
Yeah.
They've come to rely on you, Tom. Are your shoulders sore from carrying everyone? Yeah. All right, go.
I might be wrong. Is it 1/3 e to the 3x plus 1 plus c?
Oh, itchy trigger finger. So, Tom, I'm assuming you chose u to be 3x plus 1?
Oh, no, I did it a different way. Sorry. Should I tell how?
Please.
I knew that the derivative of e to the 3x plus 1 is 3 times e to the 3x plus 1. So if I want, I just need to get rid of that 3 somehow. So if you divide by 3 in the beginning, then you have 1/3 times 3 to the x plus 1. And so the 1/3 and the 3 cancel, and you just get e to the 3x plus 1.
It's not wrong.
I
I mean, is it? Yes.
Yes. Like,
Can
it's
I show you my technique?
Yeah, yeah.
Same results. So that 1/3 seems fairly trivial, but again, that is the most common mistake that people make. In general, you will remember that the integral of e to the something is e to the something. What you will forget is the fact that you have to do that as a u problem. You'll have some component out in front of it, and usually it's a constant. The same is true with the derivative of e to the something, e to the u. You'll forget to chain on that e to the u. For some strange reason, our calendar jumps from day 78 to day 84. We all know whose fault that is, right? Grassy. So that day 84 will be due on Friday. If you want to start on it now or tonight, that's great. However, you should realize that you have a quiz tomorrow, as I've mentioned numerous times. That should be your priority. By the end of the period, I will take day 78 from you over on the little table there. And last but not least, that is the Batman equation. There's actually an equation that when you type it in, it grabs out the bat symbol.
That's on the calculus test, right?
Yes, it is. If you have to memorize it.
I don't know what it's like.